Okay, so finding distance on a graph or given 2 points. We're going to start with just distance on a graph. Last week, I gave you a handout that had a problem that looked like this. Okay. And it says, draw a right triangle using the hypotenuse of a right triangle to find the distance between the 2 points. So these were the 2 points that they gave you originally. This is the diagonal. Some of you chose to draw the right triangle above, which is fine. It doesn't change anything. Okay, but I chose to draw mine this direction underneath the diagonal. What is the length of this leg here? 3. And what is the length of this one? Also 3. All right, and because these are the legs, they connect that right angle. If we do a squared plus b squared equals c squared, c is going to be the length of this hypotenuse, right? So 3 squared plus 3 squared, that's 9 plus 9, which is 18. And what's the inverse of squaring a value? Square root that. What is the square root of 18? We'll just keep it 4.2 is C. Okay, so the length of this hypotenuse is 4.2. So the distance between this ordered pair 1, 1 and this ordered pair 4, 4, the distance between those 2 points is 4.2. Okay, so let's see. What is the difference between 1 and 4? What's the distance between 1 and 4? 3. So the distance between the x values is 3, and the distance between the y values is also 3. And you can see that's where these values would have originated from. Okay, so there's a formula that we can use for this also, which I'm going to introduce to you today. First, I want you to put a point at 1, 1. And then put out an ordered pair at 4, 3. So put an ordered pair at 1, 1 and 4, 3. All right, and we're going to work on finding the distance of those. So if we find the distance between 1, 1 and 4, 3, first connect those with the diagonal, because this is the length of the line that we're talking about. How long is that line? That's the question. Okay, so let's use the Pythagorean theorem way first. Okay, so you need to find the legs of this triangle. So the horizontal leg here goes across, and then we have our other leg that is vertical. Oh, I put it at 4, 4? 4, 3. Thank you. So the length of this side is how long? The vertical? It's 2. And the length of this one is 3. Okay, so those 2 legs, that's the part that connects the right angle. So those are the legs. And so using Pythagorean theorem, it's a squared plus b squared equals c squared. It doesn't matter which one you label a and b. So 3 squared plus 2 squared. 3 squared is 9. 2 squared is 4. 9 and 4 is 13. And we have to get rid of that square by doing what do we do? What's the opposite of squaring? Square rooting. So take the square root. That's going to cancel. The square root of 13 is c. What is the square root of 13 roughly? 3.6. Okay, so that is roughly the length of this side length here, the hypotenuse. Okay, now let's look at it using the distance formula. Okay, the distance formula looks difficult, but really you've been doing it this whole time anyway. Formula. All right, so D equals, and they make a big long square root. It just means that we're doing that last. You guys are used to doing that. All right, in this first parentheses, put x2 minus x1 squared. plus, what do you think is going to be here? Very good. Y2 minus Y1 squared. What does that make you think of? What is so familiar about that? Slope. And if we're finding, slope is very similar to finding this diagonal, isn't it? Okay. So now, how do we employ this? How do we use this? Well, I gave you two ordered pairs here. This ordered pair was 1, 1, and this ordered pair is 4, 3. So let's just use those for our example since we already know what the answer is. So 1, 1, and 4, 3. That's how we're going to start our example off. Okay, so ordered pair 1, 1 is x1, y1, and 4, 3 is x2, y2. Okay, so now let's start to fill this out. To start this off, keep the square root there. It doesn't go away until we actually take the square root of something. All right, in this first parentheses, x2 minus x1, what are those values going to be? 4 minus 1 squared plus, and what is y2 minus y1? 3 minus 1, and don't forget your square on the outside. All right, now I'm going to write this out step by step. So the square root's still there. We're not going to do anything with that yet because we have to take care of parentheses first. So what's 4 minus 1? 3. Put the 2 on it. What's 3 minus 1? 2. Don't forget your square. What is 3 squared? See, we have 9 plus, and 2 squared is 4. What is 9 plus 4? So now we have the square root of 13. And what is the square root of 13? Is that the exact same thing we got up here? Didn't it pretty much follow the same thing that we did? Yeah, it just set us up so we would take the square root last in a different way, didn't it? Okay? So both methods will work. All right, go ahead and go to your Canvas assignment.